Hello everyone, and welcome to a special guest webinar hosted by the Cloud Standards Customer Council. My name is Tracy Berardi, and I'm Program Manager of the CSCC. Thanks for joining us today. Today we will explore the latest release of OpenStack and hear highlights from the recent OpenStack Summit, which was held in April in Austin, Texas. We're joined by two OpenStack experts, Brad Topol, an IBM Distinguished Engineer working on OpenStack, and Davinam Srinivas, or DIMS for short, who is Community Architect and Principal Software Engineer focused on OpenStack at his company Mirantis. If you would like to download the presentation file, we've included a link to the PDF. It's in the chat box in the GoToWebinar toolbar. If you open that up, you can access the link. And following the presentation, we'll post both a recording and the PDF to the CSCC website, our events page. We will have some time for Q&A at the end of the webinar. If you'd like to pose a question, please do so through the Questions tab in the toolbar. And with that brief introduction, I'll turn it over to you, Brad, to get started. Thank you.
All right, thank you, Tracy. Go to the second chart. So welcome, everybody. We're glad you could join us. We're going to talk about OpenStack, give it just a brief overview, then we'll talk about key features that were put into the latest release of OpenStack. It's called Mitaka. And then we'll talk about highlights from our most recent summit, which was perhaps just about a week or so ago. And some of us are still recovering from it. It was quite a fun week. So if you see here on chart 2, what is OpenStack? This is one of my favorite definitions for OpenStack. It's essentially a cloud operating system, and it controls a large pool of compute, storage, and networking resources throughout a data center. What's great about it is it's all managed through a dashboard that gives administrators control and also allows users to provision resources themselves through a web interface. So what does that really mean? Well, you know, if you think about how people would do things before they had a cloud infrastructure like this, let's say they wanted to create some type of web application where they're going to need an application server, they're going to need a database, they're going to need some networking set up. And so how would they do this? Well, they'd call whoever is the right person in the CIO's office to set up the app server. They'd call whoever is the right person to set up the database, typically a different group of people. And then they'd call somebody to help set the networking the way they like. And, you know, the way things work, and you know, before you have a cloud infrastructure, doing all those steps could take 6, 8 months, you know, depending on the organization, what have you. This could take a long time, which is very frustrating. You know, people want to move a lot quicker than that. They want to get to the point where they're just writing their apps. And with something like OpenStack, you know, everything's software defined, so you can get your compute resources and put images on them for an app server, put images on them for a database server, and you can attach storage, whether it be volume storage or object storage, and you can set up, you know, your virtual networks. So a lot of power is given to the users and the administrators, and it rapidly speeds up the deployment of people who are trying to get applications out. Another way to think about OpenStack is if you're very familiar with Amazon and their web services, they're running a public cloud. You know, when you look at OpenStack, what you're trying to do, it does also run as a public cloud, and it can also run as a dedicated cloud, but it can also run as a private cloud. So you're trying to give the folks in your organization, the folks in your company, that Amazon-like feel of being able to rapidly get resources and do what you need to do, but be able to do it in say, a private cloud where you know, you control everything and you're very safe with regards to your data safe, and you know, if you have compliance issues about how data, you know, can't be shared, whether it's, you know, HIPAA or something else, you know, there are different models that OpenStack can run at. And again, we typically think of three of them. You run private, you can run a public cloud. There's lots of OpenStack public clouds, and then some people offer you dedicated, which is what's running on their organization's infrastructure, and you kind of get it as your own private piece. So it's a very flexible cloud infrastructure, and it's all community open source, and it's been very successful, having a very huge community of developers and operators. If we go to the next chart, please. OpenStack started with the basics of having compute and network and storage, but the keeps growing and the capabilities keep growing as folks like to add new pieces to the infrastructure. So you started with your compute, and that's what you use to provision, virtual machines or bare metal, and you get your compute powers out of that. You've then got your networking capabilities to set up your virtual networks and give you public IPs and what have you. And then you started with storage, volume storage, block storage essentially, and then over time, and they also had object storage. And then over time, we added more. So as people had more images that they wanted to run on the virtual machines, you added the image management of Glance. Security became a big issue, and to have a single component that handled your identity, your authentication and access management was a component called Keystone. Over time, folks branched out and realized they wanted orchestration, and so an orchestration component called Heat, you can see in the upper right-hand corner, came about, and other things have been filling in. Better DNS management, better key management, a data processing, think analytics type project popped up. Workflow and service catalogs came as well. And then also database as a service. So making it easy to use databases and get those types of images up and running in the infrastructure. So a lot of pieces have really come together that give people a lot of choices with OpenStack to be able to leverage and tailor it for their needs. Also lots of common libraries. DIMS is one of the key folks that's always worried about making sure we have common libraries and a lot of reuse across these different projects. If we go to the next chart, please, Tracy. So when you look at if you're a company and you look at an open source project and you've got to make a judgment call, is this something we should leverage? We like to think of you evaluating this with 3 C's: code, community, and culture. So what does that mean? And we do this all the time, we evaluate lots of open source projects. Code, ideally the code is in pretty good shape. And it doesn't have to be great. What also is important is the culture. There's lots of open source projects out there, but do they really have a level playing field? Do they have a governance board set up? Do they have a foundation behind it? So, or is it, the alternative, which you have to look out for, which is quote unquote an open source project where basically a single vendor is in charge of what gets in and committed and added to the project. And the beauty of OpenStack is, the code is getting very solid now. We've been doing this for about 5 years. The community is very solid, and we'll talk about that. But that culture piece of having a level playing field, and if you roll up your sleeves and you become a person who contributes and contributes a lot, you can actually become a core contributor or a project technical lead and be able to dramatically influence the direction of different parts of the OpenStack project. So, as we look at code, community, and culture, the community is doing quite well, right? We've got, this number is 34,000. I believe that's actually up to now 50,000 of individual members of the foundation. You got 5,000 developers. Average monthly contributors are 500. We've got 261,000 code contributions, people contributing from over 177 countries, and a large number of repositories. So if you look at OpenStack from that vantage point, the code, the community, and the culture, it continues to grow. It's frankly the fastest growing open source project there is. It's growing faster than Linux. It's doing very, very well. And again, you look for those 3 C's, and that's a good sign of what's going to be a good community. Next chart, please. Lots of use cases are popping up for OpenStack. High throughput computing, scientific computing. If you look at places like CERN, where they do all the particle analysis, particle acceleration, and they smash up the particles and generate tons and tons of data, that's a very popular use case. Public cloud, web hosting, database as a service, lots of video processing, lots of big data applications where you need more and more resources. Supporting containers, we'll talk a little more about that later. And also, e-commerce. Lots of folks use this for big e-commerce sites. When it's Black Friday or what have you, and you're going to have a huge surge of e-commerce, you need an elastic infrastructure that can grow and handle the load, and that's what something like OpenStack, the cloud infrastructure, can give you. Next chart, please. So if we look at the adoption, do people really use this? Absolutely. If you look across, where have there been big adoptions and having an enterprise private cloud? Walmart, eBay, SAP, great examples. Public clouds, Deutsche Telekom and others are starting to have their public clouds running on OpenStack. Research and big data, you see folks like MIT, and one that's not listed here that's huge, I need to make sure we add, is CERN. Been using OpenStack for years to do their research and big data processing that they have. And then the new one that's really been showing up that's really exciting and putting a lot of new resources and new use cases is the telecom and network function virtualization world. So looking at AT&T and others that are seeing the benefits of, as they move to a network function virtualization model of all their advanced networking services, being able to run that in a solid cloud infrastructure is something they see as very strategic, and they're adopting. Next chart, please. The community is very strong and doing lots of great things. Again, we're doing, even since the previous summit, not just the one in Austin, but the one before that, we started doing a lot of outreach to the telecom community and building a stronger relationship with the telecom community, and focusing on their network function virtualization requirements. We have hackathons all over the world and meetup groups all over the world. Pretty much a large number of cities have OpenStack meetups. You can go, I think on the OpenStack site, you can go see the list of all the cities that have OpenStack meetups. We have not just developers meeting to get-togethers between release cycles, but operators are getting together. And so we have operators getting together to help provide feedback and steer the infrastructure so it meets stakeholder requirements. About a release or two, we actually added a product working group. So the product working group has representatives from lots of key companies, what have you, that are working together to help prioritize and drive requirements. Some people, you worry about that with an open source project. Well, what gets priority? Is there any sanity to this? Well, the product working group helps provide that voice of, hey, here's what the operators need. Hey, here's what we need for these different constituencies. So, the community is doing a lot of outreach through the product working group. And other places where the community is really growing, we'll talk about them a little bit more, is in container orchestration is becoming very, very popular using OpenStack, excuse me, and using it also not just for provisioning VMs, but to be able to use it with bare metal. So, bare metal hardware is available through OpenStack. One of OpenStack's key selling points is it's providing you the cloud infrastructure, but it's providing you cloud infrastructure that will meet a broad amount of your use cases. A lot of folks do some things with containers, they do some things with bare metal, and they do some things with VMs. And OpenStack's goal is to provide you all three of those, one-stop shopping for those three different types of usage models that you might have, and make your life easy by providing that best-of-breed infrastructure to provide you all three. Next chart, please. What's really interesting about OpenStack is they name their releases typically after related to this next city where the next summit's going to be held. And so the latest one, and they always have a letter. So this one is Mitaka. Excuse me. The next one's going to be Newton. So we're at M, then we'll go to N, then we'll go to O. And if you look at OpenStack and this latest one, again, lots of growth, lots of intensity. We just released this OpenStack on April 7th. Again, lots of folks contributing, and a large increase from the previous release. Next chart, please. So in this latest release, what were the key things that we were focused on trying to improve? User experience, manageability, and scalability. So from the user experience side, we'll talk about this a little bit more, but because you have a lot of different projects that all work together, as you saw in one of the previous charts with all the different boxes, there's been a lot of emphasis there on improving the consistency of how you interact with all the different OpenStack sub-projects, so to give you a more consistent user experience and make it easier to use. On the manageability side, we'll go into more detail, but finer grained controls, easier management, management for more advanced features related to either security or live upgrades. We'll talk about that. And then as always, an important focus for OpenStack is to continue to prove its scalability, its performance, and its stability for very large deployments. Next chart, please. So looking at the details of these, on the user experience side, there has been a lot of enhancements to what is called the OpenStack client. The OpenStack client is a unified single tool that allows you from the command line to interact with all these different services. When OpenStack first started out, each sub-project had its own little command line tool, which all worked slightly different, all used slightly different syntax, would drive our operators nuts. Now we have a single tool that all the major projects are leveraging, and the single tool gives you a single a way to interact with components, and it's very consistent, and it reduces your feeling that you're actually dealing with different sub-projects. In addition, the networking, which is always a difficult aspect of a cloud infrastructure, new simplified API to Neutron, which is the network virtualization component of OpenStack. Say, give me a network. So they put a lot of work into making that easier. If you look at manageability, easier setup of the identity server, the security aspect of OpenStack Keystone, simplified configurations for the compute aspect of OpenStack, which is Nova. And for Neutron, if you're dealing with L3 networks, if you're dealing with the distributed virtual routing support, the DVR, tremendous improvements made there to make those more manageable. And then lots of work on scalability. Scalability in the orchestration engine of OpenStack, which is called Heat. Scalability in the security piece of OpenStack, which is called Keystone. It uses a token-based model, and they've got a new lightweight token that does much better if you have very large deployments. across multiple regions. You know, they put a lot of work into making the security pieces scale. And then on the Nova Compute Engine, in its scheduler and how it's provisioning the VMs and its model for having different cells, lots of efforts have been there to improve those, the scalability of both of those as well. Next chart, please. So at this point, I'm going to hand over to my good friend and colleague, Dims, who has been working on OpenStack a really long time. He's a TC member, core contributor in multiple projects, and he's going to talk about a lot of the new key features in a little more detail that are in the Mitaka release. So go ahead, Dims.
Thanks, Brad. Hi. So this chart is really dense. There's a lot of information in it, but the main thing I wanted to drive in this chart is just to give you an idea of there are like 37 things, 38 things in this slide, and just to give you an idea of what is going on in different projects and to see if there is some common stuff that pops up in the different projects, as well as you know, give you an idea of how many people are working on these things. This is all work that was done in the last 6 months. So to peel some of the information, for example, let's take interoperability, right? So if you take, we have a test suite called Tempest, and we added plugins. Then we are able to register vendors in preparation for doing standardized testing of different environments. We have, let's take another one. If you look around, you see in a lot of projects, you see LBAS, that's the load balancing as a service. You will see containers, for example, show up in different projects. And these are essentially some of the projects that we are working on. This is by no means the entire list of projects that OpenStack community is working on. So I will go through some of the drill down into some of the key features, but this was just to give you an idea of all the vast array of work that we are doing in the community and how we are doing in the community, how we are doing these things in the community. Next slide, please. Okay, so drilling down into specifically into networking, right? For a long time, Neutron and Nova had issues on how they would coexist. Neutron was actually spun off of work that was earlier done in Nova, and we are trying to make the integration simpler by adding a get me a network function. This used to be error-prone multitask step, and we are trying to make it really simple for the operators, for the end users, and everybody as well. So the other one is integration with external domain name service. In this, what we are trying to do is you should be able to use an alternate domain name as a service provider like Designate or a custom service that is provided by other people in the community or the specific environment at a customer. We should be able to assign floating IP addresses. We should be able to assign a specific DNS domain to a network. All these things that we are doing here makes it very easy for Neutron to work in a traditional networking environment in a big data center. We also do a lot of support for telco with the network NFV and Tosca NFV profiles like that. And specifically in this release, we added announcement of tenant subnets through a centralized router gateway when you're using a BGP protocol. If you take volume storage, then some of the things that we have done here is we made it very easy and very easy for replication to happen. Replication is important for high availability and disaster recovery. We enable a user to change the type of a volume after its creation. Earlier, you didn't have that option. You had, whenever you created a volume, you'd specify a type, and that's it, you were done. You couldn't change it later. So now with changes like this, we are able to change things like, okay, is this volume compressed? Can I make it uncompressed for now, depending on what is happening in the environment and which disks you're using and things like that. Can I change the QoS settings for a volume that has a lot of usage that happens during a specific time of the month or the year? So, and the other thing is, we used to have, if we had to do things like snapshots and backups, we used to do it on an individual volume basis. Now we added consistency groups, so this helps in data protection as well as disaster recovery. So in database as a service, we specifically added features for how do you backup and restore without actually knowing the details of how these are done specifically for say Oracle or MySQL or Postgres. So the operators would use the same commands to do backup and restore, and irrespective of the type of the database. And we also added support for new databases, which we didn't have before, which is the CouchDB and the DB2 database. Next slide, please. If you take security, we've added things like one-time passwords. So essentially, if you probably have used Google Authenticator and two-factor authentication using Google Authenticator. So we added the feature in Keystone. The next step would be to add this feature in the Horizon, which is our UI that is presented to the end users and operators. So, the way this works in the community is each of the projects will start with the initiative, for example, the TOTP token, and then we will start evangelizing that to the other projects, and we eventually build a cohesive solution around it. The other important one in Keystone is if you set up federation, you are most likely to have users with the same name or something like that across the two different data sources. So when you try to register them in Keystone, we used to have a problem. Now with the concept of the shadow users, users can have the identical username, but the Keystone will know who they are and where they come from. Also, we've added things like we have added a concept called implied roles. With implied roles, what we do is if the user is a member of a specific role and the role is a member of another role, then we transitively figure out that the user is a member of the second role as well. The other feature that we added was we have a concept called domains in Keystone, and in domains, so the roles didn't used to have, you couldn't specify roles that are specific to a single domain. Now we've added that feature as well. That helps a lot with finer grain access control. Next slide, please. So if we take, what are we doing for manageability in NOVA? NOVA is the heart of most of everybody's work, since that's a compute project. So one of the things that has been an irritation in the side of the operators is live migration. Live migration is moving a virtual machine from one host to another host. Suppose if you want to take a maintenance window on a host, then you live migrate the virtual machines that are actual working workloads that are processing requests right now. You live migrate them from one host to another host, so there is no downtime, and we had several issues in this process. So we worked really hard on this. There is some more work to be done, but we enhanced the REST API and the and the client that we use to better give information on how is the live migration happening, what state is it in currently, and things like that. Also, we gave a way to separate the network that is used for live migration so it doesn't affect other traffic. We added things like scheduling filter, where you can specify that, okay, don't just randomly pick up any host with enough disk space, go for the one with the maximum disk space, for example. And of course, we added things like forcing and aborting live migrations as well. Next slide, please. So that was some of the technical details. Now I'll give control back to Brad to wrap up with the takeaways.
Thanks, Dims. So both Dims and I went to the OpenStack Summit, and let me talk about some key takeaways from the summit. Again, the great attendance at the conference, over 7,500 attendees from over 60 countries. Seeing huge adoption of growth of using OpenStack in retail, financial services, and manufacturing industries. The OpenStack community recognizes that there is a shortage of skills in having administrators that are able to run OpenStack, and so they were able to announce the general availability of a certified OpenStack administrator exam. And so there's now capabilities where people can get training and get certified as an OpenStack administrator. Another big key takeaway that people were very excited about, Donna Scott, who is a Gartner Distinguished Analyst, and who many folks remember early in the community. Donna was perhaps lukewarm about OpenStack in the early days. She was on stage at the keynote, and she was recommending OpenStack for folks who have cloud-native applications, and also as a place where their more established applications could migrate to over time. So it was really exciting having Donna up on stage as a Gartner analyst and sharing her views of OpenStack and getting that support. The other big takeaway is what we've been seeing, where there's been collaboration across open source communities to reduce overlap. So, for example, OpenStack worries about your cloud infrastructure, your networking, your compute, and your storage, but there's been these other communities, Kubernetes, for example, and Apache Mesos, that worry about containers. And then there's Cloud Foundry, which is sort of your cloud service instances broker, which is able to give you lots of services and register them and have applications hook them up to each other. These communities, and Cloud Foundry is basically your platform as a service layer, as opposed to OpenStack, which is the infrastructure as a service layer. All of these communities are working together to reduce their overlap, so that Kubernetes, for example, can use OpenStack Cinder block storage, or can use OpenStack Neutron for networking, and so having these communities work together, as opposed to everyone reinventing the same wheels at the infrastructure layer, is a huge help. And how we accomplish this is a lot of the big companies that have invested in OpenStack are also investing resources in these other communities, and making sure there's cross-pollination and making sure people have awareness. And this has been very well received by those other communities. So that's been a really exciting takeaway, to see all the large number of presentations that were given at the OpenStack Summit that somehow related to either Apache Mesos or Kubernetes or other types of containers or Cloud Foundry, et cetera, et cetera. So a lot of that great collaboration across those different communities. Next chart, please. Other key takeaways, interoperability. Key to success for OpenStack is that the different distros that are released by all the different vendors are truly interoperable. And what we saw at some of the presentations, and there's a video link here you can go look at, that was led by Don Rippert and Angel Diaz, but a huge push and challenge to the community to improve interoperability, and that was very well received. So lots of the different companies came up and handed out their cards and said, we're in, we want to do this. Fortunately, OpenStack already has a project called RefStack that is focused on interoperability, so we're not starting from ground zero there, and folks can actually send in their interoperability test results and get validation that they're seeing the interoperability of improvements that are needed, or if they find bugs in interoperability, there's a project where that can be sent into. But the huge push there and the huge excitement of growing companies willing to contribute and focus on that aspect of OpenStack is wonderful. That's great to see in the OpenStack environment. You know, in the early days, it was, well, the different vendors try to differentiate, and oh, mine's better than yours because I have a better scheduler, or some other, you know, detail that maybe wasn't as important to the customer as interoperability. Interoperability means I don't have vendor lock-in. I can take my toys and go to a different cloud infrastructure. Use case growth. What we saw at the summit were a lot of keynote presentations that had neat applications using Internet of Things, big data, and containers. Lots of cool things. There was a demo given where they were, you know, worrying about all the different temperature controls in all these different rooms in a building. Lots of big data, lots of use of containers. So big use case growth in all of those areas, and all the videos are available online at the OpenStack Foundation. So you can actually go there and see all the different topics, and they have a little search thing that allow you to search and zoom in on all these topics. And another key takeaway was the telco adoption. Really seeing how AT&T and others like Verizon and China Mobile are ramping up their adoption of OpenStack. AT&T won the Super User Award at the conference, and there's just tremendous amount of resources that are flowing into the community from the telcos wanting to use it for all the telco infrastructure that they do. Next chart. Just some links here if you want to find more information about the OpenStack Mitaka release. So those, you know, you can download the presentation and you go look for these. So lots of links there. And is there a next chart? That may be the last chart.
Yeah, and this
All right.
Trace here. I figure I'll leave this up so folks can visit them as we go through Q&A. Thank you so much, Brad and Dims, for the overview. Appreciate it. And thanks everyone on the call. We do have a few questions, and it looks like we've got plenty of time, about 20 minutes. So if anyone has other questions, you can submit those through the questions tab in the GoToWebinar toolbar. The first question that we have, a popular question, came in a couple times, is how does OpenStack work with Cloud Foundry? You know, what are the interaction points at a high level?
Yeah, so I'll take this one, and then, you know, Dims, if you want to add to it, feel free. Again, the way to think of these things is Cloud Foundry is your platform as a service, and it's providing you a little higher level application service capability that is elastic. And if you've seen these infrastructures like Cloud Foundry, and the IBM one is Bluemix, you know, there's the, you know, you set up your services, and then you can literally, you know, particularly like on Bluemix, you can click a button and say, scale, 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 I want 20 services. And so you lots of services are available. There's database services, there's object storage services available. And, you know, the goal at that platform as a service layer is to make life easier for folks writing applications. All they should have to do is worry about the application piece that they're writing, and the database services, the object services, the analysis services, all those services are then made available in that platform as a service ecosystem. Where OpenStack plays a role is it's at the lower layer, and it plugs into Cloud Foundry at what is called the CPI layer, the Cloud Provider Interface layer. So one of the, the most popular Cloud Foundry deployment is running the, when it wants to scale up all its services, it's going to need more resources, and it goes through its Cloud Provider Interface to provide those resources. And there are other things that you can plug in at the IaaS layer, but one of the options that is very popular these days, if you want a full open source stack, is to use OpenStack at that Cloud Provider Interface layer of Cloud Foundry. And then, Dims, I don't know if you wanted to add to that.
Yeah, this is a pretty popular model with several people, including Kubernetes, Mesos, other things as well. So where they take whether you have containers or whether you have PaaS, eventually you need a raw bare metal or virtual machines where to run these things, and this is a very popular thing to use OpenStack at the IaaS layer, and then make calls to OpenStack whenever they need a volume, whenever they need a network, whenever they need more compute power. That's all I had to add. Right.
Sure. Excellent.
Thank you. Let's see, next question. Who are the competitors of OpenStack?
Oh, that's an easy one.
Yeah.
The big competitors for OpenStack would be the cloud infrastructures that are not open source and not built in a community way and are more proprietary. So the big competitors there that we see would be the Microsoft Azure cloud and the Amazon cloud. And again, if you look at what OpenStack is trying to do is give people an option that gives them choice and consistency. So it's an open source thing that they can go contribute to. They don't have a vendor lock-in. It's not a proprietary infrastructure, and they can run it in a hybrid model. They can run it in a private cloud model, dedicated model, and then in a public cloud model. So that's sort of how it kind of stocks up compared to the competitors. Dims, did you want to add to that?
Yeah, sure. On the if you're looking at competitors that are within your firewalls, then VMware is a competitor, for example. But then what is happening is VMware itself has an OpenStack distribution where they allow OpenStack APIs to their customers, and people use OpenStack APIs to access VMware resources. So similarly, just in Mitaka cycle, we've added a Google driver for Cinder, where Cinder backups go to the Google Cloud. So, and we are also adding various integration points where once you have OpenStack, then we can work with your existing investments in the other cloud providers as well.
Excellent.
Thanks, Dim. That actually touches on the next question that had come in, which was about the advantages of using OpenStack over VMware for longer-term projects. So I think you touched on that. The next question is OpenStack and OpenStack Mitaka, are those synonymous at this point when talking about OpenStack, or do you just refer to OpenStack as OpenStack?
Well, it's OpenStack, and it's, go ahead, Dims, go ahead.
Mitaka is a specific release. Every 6 months we put out a release. The Mitaka is the latest one. The next one is going to be called Newton, and then we still haven't named the releases that's going to come after that. It's alphabetical. We started with A and B, and then we went on. We are at M now. That gives you an idea of 6-month cycles. How many releases we've put out. But when you just say OpenStack, a lot of people are still using Juno and Kilo and Liberty releases, but the one that we are talking about today is named Mitaka. Did you want to add anything, Brad?
No, I think you covered that really well. For whatever reason, it's a fun process. We pick a name, so and they vote on it, and we of course are going to have legal clear it, but it gives folks to try and pick just an interesting name for the next release, and it's typically related to where the city is going to be for the next summit.
Is that Newton, Massachusetts, or?
Actually, this was Austin, so there was something around Austin called Newton. So there was a good thread going on in the mailing list saying, oh, what do we do with the next release in Boston? Do we do Plymouth, or do we do Providence? Should we do New England, or should we just do Boston? Should we do Massachusetts? So it's always a fun exercise trying to get everybody excited and look up on what are the places and things that are nearby where the summit is going to be held.
Yeah, and I think for Boston we should do Dim's house, since Dim's actually lives in Boston. So that's what I'm going to put as my nomination.
Yeah, but it doesn't start with P.
We'll add a P somewhere.
And do you guys know when the next release is expected to be delivered?
Yes. I'm part of the release management team, and we put out the schedule. It's in October, early October.
Great. And next question. Is it easy to connect OpenStack on-prem with a public cloud provider like SoftLayer, Azure, or Amazon Web Services?
Can you say that again? What was the question?
Is it easy to connect OpenStack on-prem with a public cloud provider like SoftLayer, Azure, or Amazon Web Services?
Yeah, we're always trying to improve that and make that better. Certainly, we're going to have environments where you can, run OpenStack on SoftLayer. And because it's the same infrastructure, we did do some work to make that hybrid cloud model easier. There's some old presentations you can see on how we made it easy to do what we call federation across clouds for a hybrid cloud model, if you want to go see some old presentations. But that is a tricky thing, but we continue to improve that and find ways to make that better. Dims, did you want to add to that?
Yes, of course. So the idea here is you have to figure out exactly what you need to burst out from in-prem to your cloud provider, and there are many ways of doing it. And the community is always open and welcoming. We publish drivers for various things, and we have a specific design for each of the drivers, whether it is Cinder or Neutron or Nova, and people are welcome to add code. And we always evangelize how do you make your neck of the woods better work with OpenStack. For example, we have a Hyper-V driver in Nova that actually works on Windows boxes. So there is a growing community there, and we encourage things like that. Tracy, back to you.
Thanks. You mentioned earlier when you were talking about use cases, you mentioned high throughput computing. Could you talk a bit more about how OpenStack helps with that?
Well, one of the great examples that there's a couple examples. The Walmarts and the Time Warner cables and the PayPals have just tremendous amounts of transactions. And there's use case studies on the OpenStack site where each of those is able to say, we have, if you look at those types of companies, we have tremendous amount of transactions going on, and we feel comfortable running OpenStack. It gives us the scalability we need. So from that aspect, from the e-commerce side, there's the high throughput. The other one that's really interesting is CERN, which is the folks that are continuously trying to use particle accelerators and smash up particles to figure out the creation of the universe. And they've got those particle accelerators. Those particle accelerators generate a tremendous amount of data that needs to be processed and stored. 5 petabytes a second or what have you. So the other nice example that we look at that is just obscene scaling that has to be used to process that sheer amount of information is CERN and how they use OpenStack across multiple research sites, multiple clouds, OpenStack clouds, to process all that data as they risk, creating that black hole that sucks up our whole universe and ruins our life. But they haven't done it yet.
And Dims, if you wanted to comment, you're welcome, or I can move on to the next question.
Yeah, please, let's go to the next one.
Okay. Next question was, are there more hackathons expected in the near future?
Oh,
yes.
Sure. Go ahead, Jim.
Yeah, there are hackathons happening all the time. Some of them are virtual, some of them are in person. If you go to the OpenStack website, you can look at the events, and if somebody needs a specific location, they can ping me or Brad later.
Right. Are there any certification test suites in plan for OpenStack?
So we already have one, and it's called the RefStack project, and it provides a huge number of tests that are essentially, you can certify that you've got to pass all these to have an OpenStack distribution that can be trademark OpenStack. And there's different levels, OpenStack powered, OpenStack whatever. But yeah, there's been a huge effort to make sure that folks are writing interoperable OpenStack infrastructures, using the community source code, and making sure that through that certification process in the RefStack, that we have a very high quality interoperable infrastructure no matter which vendor you choose. One of the things we like to say is, if I'm going to lose a deal on the IBM side, I don't mind losing it to my buddy Dims at Mirantis. I'd rather lose a deal to another OpenStack vendor than lose it to a non-OpenStack vendor. So there's a tremendous desire between Red Hat and Rackspace and IBM and Mirantis that we provide this certification process, and you can feel comfortable that we're doing a lot of work there to make sure these infrastructures distributions are interoperable. I don't know, Dims, if you want to add to that.
Oh yeah, absolutely. So I really love this portion of the community where on the sales side, all of us are looking at different customers. We are trying to pitch to the same customers and trying to but then when we come to the community, we are all cooperating. We are working on this set of code. We are working on the same set of specifications, and we barter, we talk, we nudge each other, and essentially get things done in a way that is a win-win for both the development side as well as the operator side as well as the end users.
Okay, great. And it looks like we can wind down now, and just a little bit early, save folks, I guess, 5 or so minutes of their time. Or actually, if you want to take one more question, we just got one more. The question for you, Dims, is Mirantis supporting Power 8 as a compute node?
Come talk to us. We'll have to do something specific in your case.
Yeah, that's probably a better one to go contact.
I don't know exactly if you have. Yeah, right. Yeah, we should do that offline.
Yep.
Okay. And if you want to comment, this is a question from the same person. If you want to comment on Ceph adoption, how important it is. Hope I pronounced that right. C-E-P-H.
Oh, Ceph? Ceph.
Yes.
The storage.
Yes.
Go ahead, Dims.
Right. So, for example, in the Mirantis default, the product aspect of it, we do use Ceph out of the box. yeah, a lot of people have different options. Ceph is a really good basic one.
Right, and so the way to think about it, the Ceph is a great option. It's an option where it's one of the I guess less cost option. There's other options where if your company already have storage, you can reuse your EMC storage or your other enterprise vendor storage. So the beauty of OpenStack is you pick the option that's best for you.
Okay, great. So thank you again. I just want to remind everyone that we will post a recording of today's webinar to the Cloud Standards Customer Council website. We have an events page. You can access it from the home page. We also have posted a PDF to that page if you'd like to download today's slides. And I'll send everyone a note too so you have those direct links. So thank you again, Brad and Dims. This was a very good presentation. A lot of attendees too send their thanks through the chat box. So I hope everyone has a great rest of the day. And thank you again. Bye.
Thanks. Bye-bye.
Thanks for running this, Tracy. Bye.